Hello, SL2. Hope you guys are having a great night so far. We are getting into solving trig equations. We've had some time to work with trig identities, to work with our trig values, or our special triangles, and our unit circle, and all of those are going to come together when we work on solving trig equations. So these are equations with trig functions, and we'll be replacing them using identities. We'll be using some trig values to actually solve when we set the equations equal to 0. So we are going to work by example tonight. We're going to do two examples together, and these are straight from IB practice tests. And I'm going to keep these trig identities up at the top, and you guys have them in your notes from last time as well, so you might want to have them out. They will help as we work through these. But we're going to start off with an example where it says the trig function f is defined by f colon x and an arrow. This right here tends to throw off students. All that means is what you know as f of x. So f with the colon x arrow just means the function f that where x maps, right, to this expression right here, 30 sine 3x cosine 3x. In other words, the function f where x is mapping to 30 sine 3x cosine 3x. In other words, how is x being used? Well, this is how it's being used, as 30 sine 3x cosine 3x. And we're working between 0 and pi over 3 for our x values. The very first part of this question asks us to write down an expression for f of x, right here, in the form of a sine 6x. Well, a sine 6x. I see something with sine here. I see something with sine and cosine in the original problem. 3, if you double it, makes 6. Well, if I look back up to my trig identities, it seems that I have something that might work right here. So sine of 2 theta is the same as 2 cosine theta sine theta. I think I could maybe make this work here, right? So I'm going to come down, and any trig identity that I think I'm going to use, I'm going to put off in a little bubble over here on the side. I'm going to call this my brain bubble, okay? So I've got sine 2 theta is equal to, and I have 2 cosine theta and sine theta. Okay, so I'm going to keep that just in the forefront of my memory here, so that will help me as I work through this. And I really don't like those equal signs. So I'm going to try that. Okay. Hopefully that's better. So let's come down here, and I always like to copy the problem down, of course, have it right in front of us. So f of x is equal to, and we'll say 30 sine 3x and cosine 3x. Okay. Well, right now, this 3x might be throwing us off just a bit. It's just an added piece that makes it maybe a little bit more confusing. So if over here on the side, I can say that 3x is really just representing some angle. If I could say that, then this might look a little bit easier to work with. So now I have, let me replace 3x with theta. So now I just have 30 sine theta cosine theta. Well, I'm one step closer. I have a cosine and a sine, they're multiplied. I've got the same thing right here. I'm going to break up 30 because I need to have a 2 here as my coefficient. So let's say I break up 30 and I say 15, okay, times 2 makes 30. And then I have sine theta and cosine theta. Well, if that's the case, I pretty much can go ahead and just take this 2 sine cosine. Since I know, I have it over here in my brain bubble, I know that's the same as sine 2 theta. I'm going to go ahead and replace it with sine 2 theta. And I still have this 15 as my coefficient. Great. So I'm closer, right? Now the only thing is, earlier I took out and I replaced theta as with the 3x, right? The 3x was now taken out and I replaced it with theta. So let me put that back in. I've got 15 as my coefficient, sine, and then 2 times theta, which was really 3x. Well, now if I simplify, I have 15 sine 6x. And that is exactly what I wanted, right? 15 sine 6x. That's what I wanted, and that's where I started. That's where I've come to. So great. Now I have used my trig identity to replace my 2 sine cosine, and I have it in the form that they'd like me to have. This makes it a little bit easier because now I'm just dealing with sine instead of sine multiplied by cosine. Because the next part is telling me to solve f of x equally to 0. So if I am going to set this now equal to 0, so this was part A. We're going to continue here with part B. If this is part B, it does make it a little bit easier because now I just have to worry about my sine values equaling 0. I can divide by 15. Think about our basic steps to solving an equation. And I have sine 6x equals 0. And I'm trying to think, okay, well, when does sine equal 0? Again, if this 6x is throwing us off, we can always think of 6x as our theta. You can always replace it as theta. Okay? So if I did want to, there's that funky equal sign again. Let's try that. There we go. Much better. So let's say I have just sine theta equals 0. If that's the case, I know, right, that when theta is 0 or pi or 2 pi, my sine value is 0. And again, if you need to go back, think about the unit circle. At 0, sine is 0 because there's no y value, right? At pi, same thing happens. There's no y value. Y value is 0. There's a value, but it's 0. And then at 2 pi, sine value is 0. So if theta is 0, pi, or 2 pi, then my sine value is 0. Remember, though, my theta is 6x. So I'm going to plug that back in. Remember, I replaced it here, and now I'm going to replace it back. I can't forget about it. So if my 6x is really equal to 0, pi, or 2 pi, I now need to actually solve for x. So let's go ahead and divide through by 6. And if that's the case, I've got to make sure I divide all of these by 6 as well. Because it's not x equals 0, pi, or 2 pi, it's 6x equals 0, pi, 2 pi. So I'm going to come over here for my final answer. X should be either 0, because 0 divided by 6 is 0, or pi over 6, or pi over 3, if you simplify that one, in order to make f of x equal to 0. So if I use 0 as my x, or pi over 6 as my x, or pi over 3 as my x, my function will equal to 0. Let's go back up for a moment, though, and just double check my interval. You were asked at the very beginning to keep x between 0 and pi over 3. So let's make sure that I've done that. When you come down here, I'm just going to write that here so I remember it. 0, not a comma, is less than or equal to x, which is less than or equal to pi over 3. That's what I want to stay within my interval. Well, since 0 is the beginning of my interval, pi over 3 is the end of my interval, pi over 6 is in the middle, I'd say I did a really good job. I included every value possible within my interval. Great. We're going to do one more example together. And this one is going to start with notation we're familiar with. And we're going to be looking from negative 360 to positive 360 degrees. So we are not in radians. A hint from IB. When the question is given to you in radians, so I'm going to highlight that here. When the question is given to you in radians, you want to make sure that your answer is also in radians. So we were given our problem in radians. So I wanted to make sure that my answer was also in radians. Okay? In this problem down here, my question is given to me in degrees. So we are going to try to leave our answer in degrees throughout this problem. Of course, I always want to copy my problem down. And for this one, I'm noticing that I have a cosine 2 theta, and then I have a cosine without the double angle. Whenever this occurs, I want to replace so that I have the same, that the same function I'm working with. Instead of cosine and cosine 2 theta, I want them both to be either cosine 2 theta or both to be cosine. And we're going to switch our cosine 2 theta because that's an identity that looks like we can use it. So I'm going to come up here to the cosine 2 theta, and I know that I can replace that with 2 cosine squared minus 1. So I'm going to come down here, and again, in my brain bubble on the side, I just want to save it for later. Cosine 2 theta can be written as 2 cosine squared theta minus 1. And I'm going to save that for later because I'm going to need to use it here in just a moment. So let's do that. This cosine 2 theta, I'm going to keep my 2 coefficient because that needs to stay. But what was my cosine 2 theta is now going to become 2 cosine squared minus 1. I'm going to bring everything else down, and then I'm going to begin to simplify. While you guys are taking notes, a good habit is to write yourself some comments on the side so you know why you did certain things when you're working through, especially a long equation like this. So I am going to write myself a note that we substituted first. So I'm going to substitute here, okay? And now we're going to simplify. Some steps when you guys work through your notes, you might not need to write yourself a note on the side. However, I guarantee there will be a couple that, oof, if you had written that note, it probably would have saved you from searching through your notes and trying to figure out what in the world you did to get different answers that you do, all right? So there's my guidelines, my substitution. I've now done that. Let's simplify. I'm going to distribute this 2. So I've got 4 cosine squared theta, and then distribute the 2 again, negative 2 plus 4 cosine plus 3. Let's continue to simplify. So 4 cosine, and my commutative property tells me I can put my plus 4 cosine here. I can bump that negative 2 to the end, and 3 and negative 2 are like terms, so now that gives me the positive 1. This is exactly what I was asked to do. I was asked to rewrite and show that this function may be written as f of theta equals, I'm going to bring that down, f of theta equals 4 cosine squared plus 4 cosine plus 1. I have done that. We have now rewritten it. And we now are dealing with just cosines. A cosine squared and a cosine and then a constant at the end. Start to think about what that looks like to you. We're being asked now to set this function equal to 0, very similar directions to the first problem that we did together. And as I'm doing this, I'm noticing that I'm going to go ahead and start part C here. I'm noticing though that I have a function squared, then I have that same function not squared, and then I have a constant. If I come over to my little brain bubble, this looks a whole lot like, well, what if I just replaced cosine, right, with x? I would have 4x squared plus 4x plus 1. What does that look like? There is my quadratic, okay? If I have a quadratic, then I can factor it just like I factor quadratics. This works great. Okay, just like you factored quadratics back in Algebra 1, Algebra 2, right? So let's do that. If I factor this out, I'm going to have 2 cosine theta plus 1 and 2 cosine theta plus 1. These are both the same exact factors. So if I took one of them, remember you want to set both factors equal to 0 here, but since they're exactly the same, you're really going to get the exact same answer. So we're going to keep this cosine theta equals negative 1/2. And to finish out your notes tonight, we're going to ask you to go ahead and solve for theta. So think about when cosine theta is equal to negative 1/2. So find theta. Remember, we are between negative 360 and positive 360 degrees, and my hint to you is that there are four values.